Why does fire exist? It sounds like a childish question, almost too obvious to ask. Fire is everywhere. Candles, stoves, campfires, sparks, explosions. You strike a match, and suddenly, light, heat, movement. So familiar that we stop being curious. But that's exactly why the question matters. Because fire is not a thing the way a rock is a thing. It's not an object you can hold. Fire is something that happens, and once you slow down and look closely at what's actually happening, fire stops being ordinary. It becomes a clue about how atoms behave, about how energy flows, about why trees grow, why the sun matters, and why the world doesn't simply sit still forever. Let's start with something simple, a piece of dry wood. It's been lying there for years, maybe decades, surrounded by air the entire time, oxygen everywhere. Nothing dramatic is happening. The wood doesn't glow. It doesn't heat up. It doesn't react. Just silence. But here's the strange part. The atoms inside that wood and the oxygen molecules around it are not indifferent to each other. In fact, they strongly prefer a different arrangement. Carbon and oxygen want to bond. When they do, energy is released. A lot of energy. That bonded state is more stable, lower energy, more comfortable in a physical sense. So why hasn't it already happened? Why doesn't the wood just burst into flames on its own? Because wanting to change and being able to change are not the same thing. Between the current state and the lower energy state, there's a barrier. Not a wall you can see, but an energy hill that must be climbed. At room temperature, atoms are always moving, colliding, bouncing, separating, millions upon millions of collisions every second, but they're moving too slowly. They collide, recoil, and drift apart again, over and over. Year after year, the reaction is possible, but it can't get started. The system is stuck. This is what physicists call a metastable state, a condition that looks stable, even though it isn't the most stable option available, like a boulder balanced near the top of a hill. It wants to roll down, but it needs a push, and that push is heat. Heat is just motion, nothing mystical, nothing added from outside the universe. When something gets hot, its atoms move faster. They vibrate harder. They collide with more force. So when you strike a match, you're not creating fire. You're giving a small group of atoms just enough energy to move fast enough to climb that invisible hill. Most collisions still fail. Atoms hit, recoil, and separate, but a few succeed. A carbon atom and an oxygen molecule get close enough to snap together. And when they do, energy is released. That released energy doesn't disappear. It goes straight into motion, making nearby atoms move faster. Those faster atoms now have a better chance of climbing the barrier themselves. They react. They release energy. They heat their neighbors. One reaction becomes two. Two become four. Four become eight. The number of reacting atoms doubles. Again and again and again. All in a fraction of a second. This is why fire doesn't slowly fade into existence. It erupts. What you're seeing in a flame is a runaway chain reaction, a feedback loop where heat creates reactions, and reactions create more heat. Once it starts, it sustains itself. That's what fire really is. Not a substance, not a material, a process, a self-amplifying cascade of atoms rearranging themselves as fast as they possibly can. And the heat you feel, that's not a thing either. Heat is not a fluid. It doesn't flow like water. Heat is atomic motion. When you hold your hand near a flame, you're feeling atoms in the air, colliding with the atoms in your skin, faster and harder. The faster the motion, the hotter it feels. Place a metal pot above a fire, and the same thing happens. The chaotic motion of atoms in the flame is transferred into the metal. The metal atoms vibrate faster. The pot gets hot. Nothing is being added. Energy is just being redistributed. Now notice something strange. The fire keeps going, only as long as that loop remains intact. Remove the fuel, and the reactions stop. Remove the oxygen, and the atoms can't rearrange. Cool it down enough, and the atoms slow below the threshold. Break any one of those conditions, and the cascade collapses. That's why fire spreads, and that's why it dies. But this raises a deeper question. If fire is just carbon and oxygen snapping together, where did that carbon come from? The wood didn't create it. It came from somewhere else. And to understand that, you have to stop looking at the ground and start looking at the air. That carbon didn't come from the soil. That's the mistake almost everyone makes. We look at a tree and assume it grew out of the ground, but the ground didn't lose hundreds of kilograms of matter. When the tree grew, the air did. Trees are built mostly from carbon, pulled directly out of carbon dioxide from the atmosphere itself. The soil contributes minerals, tiny amounts. That's what becomes ash after a fire. But the wood, the bulk of it, that came from the sky. Rain provides water, air provides carbon, and sunlight provides the energy. Because carbon and oxygen don't separate themselves. They resist separation. To tear carbon dioxide apart, you must push atoms uphill energetically. And that work is done by the sun. Every leaf is a microscopic factory using incoming sunlight to rip oxygen away from carbon and lock the carbon into solid structure. That process is photosynthesis. It is, in a very real sense, the opposite of fire. Fire brings carbon and oxygen together. Photosynthesis forces them apart. Fire releases energy. Photosynthesis stores it. For years, sometimes decades, a tree patiently collects sunlight, photon by photon, using it to hold carbon and oxygen apart in an unstable arrangement. That instability is stored energy. So when you burn a log, nothing new is created. You are simply letting atoms return to where they wanted to be all along. Carbon collapses back toward oxygen. The stored energy is released. Heat, light. The flame, you see, is sunlight returning, not metaphorically, literally. Sunlight that struck a leaf years ago was converted into chemical tension, and now that tension is snapping loose. Every flicker of flame is recycled solar energy. The light, the warmth, even the motion of the air above the fire, it all traces back to the sun. And here's the part most people never realize. Your body works the same way. Every breath you take feeds oxygen into slow, controlled reactions inside your cells. You combine carbon-based molecules with oxygen to release energy, not explosively, carefully. You capture that energy to move, to think, to stay alive. Fire and metabolism are the same chemistry, running at different speeds, which means something profound is true. You are not separate from fire. You are a regulated flame a slow burn powered by ancient sunlight, circulating carbon through your body before returning it to the air, the fire in a fireplace, and the fire inside your cells are part of the same cycle. Energy flows. Matter rearranges. Nothing is wasted. And once you see that, fire stops being destructive chaos. It becomes a message, a reminder that the world is not static, that energy is always moving, that stability is temporary, and that every flame is just the universe finding its way back downhill.